Okay, so what is mass spec? Mass spectrometry is primarily used to determine the molar mass, which we've said before. It primarily determines the molar mass and the formula of a compound. It's very useful in finding the formula also. Okay, we're going to primarily do it to get the molar mass. Now, let's talk about what a mass spectrometer does. So first of all, you get a compound. That's the thing you're trying to analyze. You get a compound and you vaporize it. And then you ionize it, and then it falls apart. That's basically it, okay? The masses of the things that fell apart, the masses of the ions are detected, and they're graphed. And that right there is the mass spec, okay? So a compound is vaporized, and then it's ionized, and it falls apart. And when it does, we measure those pieces, and we graph them. All right, so let's talk about how it happens. So the most common method of mass spec is electrospray, electron impact, where we shoot high energy electrons at some sample. So let's take this as the sample. We shoot high energy electrons at it, and when we do, one electron is ejected. Okay, so after it's ejected, we have basically the thing we started out with, except one electron, and it's charged. Okay. So the mass of this thing that we get is essentially the same as the mass of this, because electrons have negligible mass, right? That's basically massless. It's very small. It's at 1/2000th the size of one proton, right? So the radical cation remains intact, and for some of this, right, the radical cation remains intact, and it's known as the molecular ion. So we're going to use that term, the molecular ion, and we're talking about this thing right here. It's the same thing as the compound that we're analyzing, except it's missing one electron, so it's got a plus charge on it. That's known as the molecular ion. Now, as I said before, it also falls apart, right? So some of these molecular ions will fall apart. When they fall apart, you've got a radical here. This electron will come over here, boom, go over to this guy. He's neutral, right? But this half is charged, right? Because the electron left. So here's another charged particle. So the first charged particle we had was really that, right? The next charged particle we have is some fragment of that, right? And these ions are then shot down a tube, and they're deflected by a magnetic field, and their mass to charge ratio is detected. All right, so we can find if we have one charge on this, the charge will be 1, and the mass will be, if these were hydrogens, right? 12 plus 1 plus 1 plus 1 is 15. Right? So the m per z here for this piece would be 15, right? Now, neutrally charged fragments are not detected, which was said a moment ago. So the mass spectrum of methane, let's look at that. So with the mass spectrum of methane, the relative abundance of each cation was detected, and so we've got the first one is the molecular ion, right, which is going to be right? And what does this weigh? This weighs 12 plus 1 plus 4 is, did I get that right? 12 plus 4 is 18. Is that right? Okay. And no, 12 plus 4 is 16. That was bothering me. I'm looking at this graph over here and I'm looking for 18. It's really bothering me. There it is. 12 plus 4 is 16, right? And sure enough, there's my 16 right there. So this peak, that is this in mass spec, if you were to do mass spec of methane, which is done here, then you'll eject one electron, and that'll make a plus. So that's this piece right here. Now, as it fragments, another piece will be, right, so this might go here, and this will be left with, right? There's another piece, okay? And that's represented by that peak, okay? So this can keep going. I think I've got that in the next slide. So this is the m plus z equals 15 peak, right? But this can keep going, where you might have another fragmentation here of another hydrogen atom that comes off. Hydrogen radicals can keep coming off of here and making smaller and smaller pieces, right? So you might get something that goes like that, and then you've got just a second here. Let me go back. It was really early in the morning here. All right. So you've got, right, one electron goes here, the other electron goes here, and you've got right, and this will give you 12 plus 1 plus 1 is 14, and right, and you'll get, let me go back to that previous page, and you've got a peak at 14, right? And the same thing happens as they continue to fall off. All right, so that's what mass spectrometry is. Essentially, you're taking a mass spectrometry. Essentially, is you're taking a piece, you're taking a sample, a compound, a molecule, right, and you're breaking it up into all possible pieces, and the most common pieces will have the highest peaks, and but all pieces will be represented. That is, if they're not negligible in population. All right, so mass spec is used for a lot of things: pharmaceuticals, biotech, clinical, and so on.